Welcome back. Today I'm going to be going over this SAT quadratic question. And once again, thanks to Anico.ai for providing this question in their free resources tab. But before I dive into the explanation, please give this a try yourself. Okay, so here we have a parabola, y equals f of x. And of course, this is standard form of a parabola, of a quadratic, a, b, c are constants. The x-intercepts are k minus 1 and 2k plus 5. They tell us that if f of 3 equals f of 17, which of these four choices is the value of k? Okay, so right away, right, a few things to kind of look at, right? They give us the x-intercepts, right, k minus 1 and 2k plus 5. And they also tell us that f of 3 equals f of 17. Now, they also tell us that this is a parabola, but of course you should already know it's a parabola because it's a quadratic. But they do tell us it's a parabola, right? So right away, what I would do is actually focus more on the x-intercepts in this f of 3 equals f of 17 part and focus less on the actual function itself. Because you see, this function has a lot of constants, a, b, and c, and you usually don't want to deal with constants when you're in SAT math, right? Especially when you're only given like this much info. So how do you find the value of k then if you can't find f of x in the first place? Well, the key is to realize, first of all, that a parabola has, that first of all, this is a parabola, right? And if you draw a parabola for a second, right, and this is not going to be accurate because I actually don't know what the parabola looks like, but let's say it was something like this, right? Once again, I don't actually know what this looks like, but let's say it was like that. Now let's just call this f of x. And they tell us that the x-intercepts were at k minus 1 and 2k plus 5. Right, so let's say that this is 2k plus 5, this is k minus 1. And I'm just going to write f of 3 equals f of 17. Okay, so you might be wondering, well, okay, wait, how do you even find the value of k then, right? You don't know the parabola, but there has to be some way to solve the value of k, right? Well, the reason I told you to first notice that this is a parabola is because right down the middle, right, we call this an axis of symmetry, right? Right, an axis of symmetry. And the unique thing about a parabola is that the distance from this axis of symmetry to a point or to the x-intercept, right? Those distances are the same, right? And the reason is that a parabola is symmetrical in nature, right? So we know that these distances here, right, from each of the x-intercepts to the center, you know that those are the same, right? So, well, how do you know what the actual axis of symmetry is? Well, think about it. What is a formula we can use to find the midpoint, right, or the middle of two other points? It's the midpoint formula, right? So if you apply that here, we get k minus 1 plus 2k plus 5, right, divided by 2, right? Because the midpoint formula is first point plus the second point divided by 2. When you do that, you get 3k plus 4 divided by 2. Alright, so now they also tell us that f of 3 equals f of 17. Let's say f of 3 was here and f of 17 was here, right? So this is 17 comma f of 17. This is 3 comma f of 3. Another thing you should know about parabolas is that if the y values are the same, which in this case they are, right? Because they tell us that f of 3 equals f of 17. If the y values are the same, right? That means that those points are actually they're equidistant from the axis of symmetry, right? Which means the distance from one point to the axis is the same as the distance of the one point from the axis. This is only true if both of the y values are the same, right? And the reason, by the way, why this also works for x-intercepts is because the y value of an x-intercept is 0, right? So they have the same y values, right? Therefore, they're also equidistant, right, from the axis. So now that we kind of know that, well, what is the midpoint between this and this, right? Well, in terms of x, right, if you apply the midpoint formula, you have a 3 and a 17. So if you do 3 plus 17 divided by 2, you get 10. So you know that this axis of symmetry here is that x equals 10, right? Because that's halfway between x equals 3 and x equals 17. So now we know that x equals 10 is the axis of symmetry, right? X equals 10. But remember, we figured out earlier that 3k plus 4 over 2, right? The midpoint that we found earlier between these two x-intercepts, that also is the axis of symmetry, right? Because we're essentially finding the midpoint between these two, right? Or in other words, we're finding the middle x between x equals k minus 1 and x equals 2k plus 5, right? And then we got this as our x1. So now we have an axis of symmetry of x equals 10, and we have another representation of that as this. So you can set those equal to each other. Okay, 10 equals 3k plus 4 divided by 2, which is 20 minus 4 over 3 equals k, which equals 16 over 3. So k equals 16 over 3, and that matches with answer choice D. So, what's the key thing to realize in this problem? Well, first of all, right, given that this is a parabola, you can leverage the fact, right, that it's symmetrical in nature, right? And using that idea, right, well, you know that f of 3 equals f of 17, right? And because if two points of a parabola have the same y value, right, that means if you find the midpoint, you get the axis. And then you can leverage the knowledge that you've gained from that, right, from the symmetry, to get the location of the axis of symmetry, which you can then use to find the value of k, right? Only thing that stays the same in a parabola, right? Or you can think of it as this way, right? The axis of symmetry is fixed, right? So any points around it will be symmetrical, right? Any pair of points, right, with the same y value, they're going to be symmetrical. So that's why these are equidistant from the axis, right? That's why these, right, are equidistant from the axis here. So once again, that's how you did this problem. I hope that made a bit of sense, and if it didn't, right, please leave any questions you have down in the comments. Once again, thanks for watching, and I'll see you next time.